Hello, I'm Quentin Wright, and I'm here to tell you how to do a successful test. Successful test starts with functional testing. We want to verify the requirements of the design are being met. You start with black box testing. After that, and the four main techniques for black box testing are unit testing, integration testing, system testing, and acceptance testing. Let's talk about unit testing for a moment. Unit testing is a white box test. It's used to test single components of a system. As a general rule, your unit tests are granular. You start with very small parts of the system, and you build to more complex parts of the system. It's usually performed by the developers. A unit test can be performed in the debugger of an integrated design environment or an integrated design environment for software in most cases. You can watch variables there, and you can actually perform your white box testing right there. Because all you're really trying to do with white box testing is ensure that the code is working properly. This is just what the developers do before they hand the code off to someone who will do a more thorough test. Now, unit testing can be repeated if there's a problem in a regression test later on, but we'll get to that in a little while. Integration testing. Integration testing is also white box testing, but instead of dealing with small pieces or fully functioning components, you're testing modules as a combined group. There are multiple approaches to integration testing. You have the top-down approach, where everything above the component that you want to test is real, and everything below it is fake or a stub. You have the bottom-up approach, which is exactly the opposite of that. Your real component is the one that you're testing, and everything above it is what's called a driver, and it just fakes the information that would go into the tested unit. And then the Big Bang approach is the approach where you look at the top and the bottom at the same time. It's a combined approach. So here's a little bit more about top-down and bottom-up. The highest levels integrated and tested first in the top-down version. Progressively lower levels are integrated and tested next. You can test an entire system using top-down. Bottom-up is the other way. Lower levels are integrated and tested. The higher level modules are integrated and then tested next. So you're working your way up instead of working your way down. When you look at Big Bang, you see integration of all units happens simultaneously. Basically, everything's tested at once. It's difficult to find failures due to testing as a whole, and if any bugs are found, integrated modules have to be detached, and then you run it again to see where the problem is. System testing is testing the finished system from the beginning all the way to the end. It comes after integration testing. It combines the hardware and the software to test. So you're basically taking the system or the software and you're running it on the desired system. It's the last step in the testing process. When you have a successful system test, you have a completed project. Acceptance testing is the first and last technique that's done. In this case, what you want to do is make sure that you are creating the project that conforms to the design document that you have. It's done after the system has been built and the other testing techniques have been done. Acceptance testing can also be done throughout the life cycle of the test. So you want to constantly keep an idea. Am I still building the project based on the design document? Have I strayed from what my goal was in the beginning? So in the case of acceptance testing, we're testing performance, reliability, functional correctness, and other elements of the design document. Now, sometimes systems change, and in the case of a change in the system, you're going to do what's called a regression test. And the regression test simply verifies that the components continue to operate after the system is changed. Regression tests are generally done after a new feature is added or a fault is removed. During regression, previous tests are rerun to confirm the components are still working. So you're running a lot of tests all at one time, but you're running the same tests as you've ran before, so they're saved. It's not a super lengthy process. Let's talk about some different types of black box tests. You have boundary value testing, which is used to test the edge cases of valid inputs. It has multiple levels, so you can either go weak or strong or robust or strong and robust. And what that basically means is that you can have a small set of just valid inputs. You can have a larger set of valid inputs. You can have a set of inputs that include invalid inputs, or you can have a large set with both valid and invalid inputs. Then you have equivalence partitioning class testing, which tests partitions in your software. If you have a piece of the software that is grouped, say you have a set of ranges that you treat differently. So you have a set from 1 to 100 is treated one way, and 100 to 200 is treated another way, and 200 to 300 is treated a third way. Then you're going to use equivalence partition class testing, and you're going to set those partitions up on the boundary values, because those functions are treated differently based on those inputs. So you're going to, and the thing about equivalence partitioning class testing is you want to make sure that you're getting something from every range when you do your test. And then lastly, you have decision table testing. It's another black box test. And in the decision table testing, you have what's considered a rule. This group of inputs in this configuration equals this output. So you want to test every single rule, and then you've tested every possible input configuration, and you know that your software is running correctly. Well, that is my presentation. Unfortunately, Jason couldn't be here today to help out with that, but I hope everyone's a little more clear on what a successful test is. Thank you.